As you saw in previous video, conditional probability can be a little bit tricky. So here's a quick review of the concept of conditional probability. Given events A and B, conditional probability is the probability of event B occurring, knowing that event A has already occurred. Now here I want you to pay attention. What first happens is event A, and then event B happens. And our focus is actually of the event B in conditional probability. And the notation is P, probability of B, this bar means given A. Okay? And here's the formula. Probability of B given A equals probability of A and B. This upside down U means and, divided by probability of A. Now here I want to remind you that in statistics, probability in particular, a lot of it is how you read the problem and analyze the problem. You have to understand which is which and match the concepts correctly, and that will make your calculation very easy. The real math behind it, what we traditionally call math, is nothing more than, frankly, arithmetics, divisions mostly, and decimal points. Okay, so here's an example 1. Michelle drew a card from a standard deck of playing cards. What's the probability that he drew a queen, given that the card was red? So in this case, red card is A, and a queen is B. And we want to know the probability of B given A. Now, we know the probability of A is to draw a red card out of 52. So out of 52, I have 26 red cards. That's my P of A, probability of A. And then probability of B, which is I only have 4 queens out of 52 cards. And the probability of the two happens together, P of A and B. I have to multiply these two fractions together and then divide it by probability of A, and that's an easy one. Notice that, that's 52, sorry about that, 26 over 52, because it's 26 red cards out of 52 total cards. These two fractions can be canceled, and then if I were to simplify that, that's 4, that's 1 in 13 chance that the card I draw will be a queen, given that it was a red. Now let's look at the second problem. A number from 1 through 100 is randomly selected. What's the probability that it's a perfect square, given that it's an odd number? So I want a perfect square, but given that it's an odd number. So my probability of B, so an odd number has to happen first, but my focus is the event B, which is a perfect square. So that equals probability of A, which was odd number. 1 to 100, there are 50 of them, that's odd number. And perfect square, how many perfect square do I have? I should have 10 perfect squares, right? 1 squared, 2 squared, 3 squared, 9 squared, and then 10 squared. Yeah, so there are 10 perfect squares out of 100. And then I divide it by the probability of A, which is odd numbers. And these two gets canceled. My final answer is 1 over 10. Okay, let's look at number 3. You do have to read these very carefully. There's 62 people that take yoga class and 48 people that take spinning class at the gym. 15 people that takes yoga also take spinning. So if I were to set this up, I like to set this up in a Venn diagram. I know 15 people that does both. So I subtract 15 from 62. I have 47 people only does yoga, but not both. And I have 48 minus 15. So I have 33 people that only does spinning, but doesn't do yoga. And 15 people in between that does both. Now let's look at the last sentence. I want to know what's the probability of a person takes yoga class if I already know that they take spinning class. So this is the first event. And in the first event, my total number of people is 48. It comes from here, right? And out of 48 people, so that's my total universe already. How many of them are taking both? It's 15. So 15 out of 48, it simplifies to 5 over 16. That's the probability there. So it's really important to read these questions carefully. Okay, number 4. Of the 30 students in Mrs. Smith's math class, 13 are athletes and 9 are in a band. 3 of the athletes are also in band. If one student is chosen at random, find the probability that this student is in band if it is known that they are not an athlete. So I gave you the diagram. There are 30 students in total, which is not represented here, but 13 are athletes, and they're all in that blue circle. And then there are 9 of them are in bands, and they're in the red circle. The 3 in between is the students who are in both. So that's how I split up those numbers, right? And now let's analyze the final questions here. Is that what we already know is that they're not an athlete, not an athlete. So if in total there are 13 athletes, the not athletes group or events is 30 minus 13, which gives me 17. So now I'm asked to find the probability that the student is in band. Total student in band that's not an athlete is 6. And then, therefore, out of all the non-athletes, the 6 kids who are in band, that probability is simply 6 over 17. You can convert it into a decimal, or you can leave it the way it is now. Okay?